When I worked for the NTSB, I assisted in investigating two international accidents: China Air Flight 611, a 747 accident in 2002, and Linhas Aéreas Sul-Americanas, or LAS, a DC-9 accident in 2003. Once another NTSB accident investigator determined China Air 611's long-ignored structural repair was the cause of the catastrophic breakup, I researched the accident aircraft's major repair inspection schedule. With LAS, I was solely instrumental in concluding that an STC, a supplemental type certificate, was used to modify the accident DC-9. The STC had been written wrong, which led to the failure of the main floor. The odd caveat was the last LAS DC-9 was released from a U.S. certificated airline, so the STC originated in the United States. International accident investigations are tricky. You play by other people's rules. Investigating a foreign accident greatly differs from investigating an accident that occurred inside the U.S. There are many components, aside from the language hurdles, that foreign investigations become challenges, such as 1. Regulatory differences between the FAA and foreign countries' aviation authority. 2. Basic technical knowledge of the aircraft. 3. Understanding of how an aircraft is maintained. 4. Training for both pilots and maintenance. 5. How parts and components are engineered. 6. Warranty items. 7. Orders such as airworthiness directives. 8. Manufacturing techniques. And 9, most importantly, the latest and greatest technology and improvements. Many foreign investigatory agencies don't see too many major airliner accidents. These investigators face an unforgivable learning curve. Foreign investigators are really tested with new technologies, especially those who never worked with digital technologies. They are often limited to comprehending analog technologies, just like the NTSB investigators do. Foreign investigatory agencies investigate under ICAO Annex 13. They may ask other investigatory agencies, like the NTSB, to assist at great risk. Why? Because it's a waste of everyone's time and an obstruction to the advancement of safety when an agency like the NTSB sends in NTSB investigators who impede the discovery of root cause and set safety back by not knowing their job. Like what happened with Lion Air 610 accident. As promised in the last episode, we're going to examine two MAX accidents, 737 MAX accidents that caused all headlines and speculation to be brought to bear against Boeing manufacturing. You see, this must be understood. Boeing provided what it promised. The Boeing 737 MAX did everything Boeing said it would. But what happens when an airliner just doesn't understand what they are buying? Caveat emptor. Buyer beware. Hello, I'm Stephen Carbone, and this is By Reason of Air Safety. On October 29, 2018, 13 minutes after departing Jakarta, Indonesia's airport Soekarno Hatta International Airport, Lion Air Flight 610, a Boeing 737-8 MAX airliner, impacted the Java Sea just outside Tanjung Karawang in West Java. The accident investigation was conducted in accordance with Annex 13 of the International Civil Aviation Organization, ICAO. The investigating lead agency was Indonesia's Komite Nasional Keselamatan Transportasi, the KNKT. Loosely translated into English means the National Transportation Safety Committee. Contents of the report demonstrated that the KNKT was investigating technologies beyond their comfort zones. KNKT never saw such technologies in an investigation. They could never imagine the upgrades, the engineering improvements of the 737 MAX. The fact that KNKT led such a complex investigation was questionable. The KNKT accident report is 322 pages long. It didn't contain probable or root causes, at least none that showed up in a word research. There were conclusions, also known as findings, and recommendations, which, in part, didn't make sense. What was most troubling was the use of speculation in place of facts. Opinion words such as the word may was used 128 times. Could was used 84 times. Might was used 28 times. And should was used 159 times. That's almost 400 times in 322 pages that investigators speculated in a factual report. KNKT and the NTSB accident investigators, who were trusted to be professional, inserted conjecture, not facts, into this accident report. Opinions are the polar opposite of safety root causes. Yet the KNKT, like the NTSB, employed opinion throughout the entire accident report. Reading through the synopsis on PDF page 20, the 10 pages of the improperly named factual information beginning on PDF page 21, and then reviewing the timeline advancing to the accident, the narrative was surreal. I had only the report. I had no access to evidence, so my opinions is the actions taken by the crews of both Flight 043, which was the accident aircraft's previous flight, and Flight 610, the accident flight, were uncharacteristic of commercial flight pilot training. These were my opinions based on the report. The fact that KNKT and the NTSB never employ investigators with technician experience, my view of the aircraft maintenance performed on the accident aircraft was technical expertise was either non-existent or technicians were told to stand down, let the airplane heal itself. And in this age where we are now, when airplanes think for themselves, having aircraft technicians with no understanding of the aircraft only leads to tragedy. This episode of By Reason of Air Safety will look at 1. Two flight crews' actions. 2. Maintenance concerns. 3. Questionable possible politics involved. And 4. Incompetence on behalf of investigators unfamiliar with the airliner and the industry. As I stated, the KNKT accident report is 322 pages long. We're not going to analyze the reams of electronic documentation because the true causes of the accident can be found on the first 30 pages. For root cause analysis, one only has to go to 20 pages into the report to see the disturbing patterns and unprofessional behavior that were major contributors to the accident. We have to go back to the day before the accident, when the accident aircraft was in Denpasar. Its speed and altimeter flags wouldn't stow on the captain's flight display. Technicians in Denpasar replaced the left-hand angle of attack AOA vane. Whether this action helped or made matters worse, the report never looked at. An AOA replacement was not a common fix. In my experience, AOA vane replacements are usually due to damage, like being struck by a ramped ground vehicle or an extended bridge. It looks like a technician tried to troubleshoot the problem, throw a part at the problem, or called Boeing for technical assistance. We'll never know. However, the AOA installation did not receive a proper return to service check. What does that mean? Well, either 1, the AOA was not correctly returned to service. For example, the technician did not properly follow Boeing's technical data for the return to service. Every component replacement on an aircraft, no matter what system it's in, has a return to service. 2, the AOA was bad from stock, that the AOA component was not airworthy item before it was installed. Which brings the question, did replacing the AOA vane cause other problems to come up in the accident aircraft? Or 3, the avionics problem that replaced AOA vane never fixed the problem, but the plane was launched anyway. There are other reasons to be suspicious of the AOA replacement. For one, in Monado, the technician, called an engineer in other countries, didn't perform required parts of the AOA test because of rain. Instead, he performed tests in the avionics bay. Were these approved methods for testing the AOA? Did the unofficial test performed affect the test results? And did he print off the test results from the aircraft's computer? KNKT didn't ask. 2. Before departing Monado, the flight crew mentioned the problem appeared in several times on the flight into Monado and requested more to be done to rectify the problem. The engineer convinced the pilots to bring the AOA problem to Denpasar. Now, was the AOA system even allowed to be deferred per the minimum equipment list to allow it to fly? Could the airplane be dispatched from Monado in an airworthy condition with this deferral? And why did the captain not refuse the airplane? The KNKT didn't ask. Then in 3, in Denpasar, the engineer replaced the AOA vane, but used an alternate method of testing. It was a legitimate test, but did he print off the test results from the aircraft's computer to verify he was seeing what the readings were reading? And 4 was the most important reason to doubt the Denpasar engineer was that during the investigation, post-accident investigation, the Denpasar engineer tried to con the investigators with pictures he said were of the accident aircraft's instrumentation, but were found to be of another 737 MAX's instruments. How can the Denpasar engineer be trusted after trying to use false documentation in an investigation? Did the Denpasar engineer really accomplish the correct AOA test as he said he did? The KNKT wasn't concerned. The KNKT tracked the different aircraft maintenance manual task codes, functional tests, and listed every cool-sounding abbreviation they could find. But did the KNKT actually have a qualified technician run the tests for them to see what the tests do? I've seen firsthand how technicians and inspectors for airlines who know the accident investigator has no idea what they're looking at will take advantage of an unqualified investigator's ignorance. Just like the Denpasar engineer with the phony pictures tried to do. Incidentally, speaking of which, let's be honest. If a technician engineer thinks he can falsify pictures of a digital aircraft's displays, do you really want him working on your airplane? On PDF page 20, the KNKT report gave a timeline about the previous flight from Denpasar into Jakarta, the Flight 043 trip. According to the report, the installed left AOA, the angle of attack sensor, had a 21-degree bias, which was undetected during the installation test in Denpasar. Remember what we're talking about. This is the guy with the false pictures, didn't detect the 21-degree bias. The erroneous AOA resulted in different indications during the flight from Denpasar to Jakarta, including 1, an indicated airspeed disagree light. That was a difference between the captain's and first officer's airspeed indicators. 2, then there was an altitude disagree, again, between the captain's and the first officer's instruments, in this case, the altimeters. 3 was a field differential pressure light was illuminated. 4, there was an activation of the infamous Maneuvering Characteristics Augmentation System, the MCAS. And 5, and last of all, the left control column stick shaker activated throughout Flight 043's duration. This was the captain's stick shaker announcing that the aircraft was stalling, but not the first officer's stick shaker. That didn't activate. The flight crew for Flight 043 was able to stop the repetitive MCAS activation by switching the stabilizer trim to cutout. Recall what I just asked. Did replacing the AOA vane cause other problems? The field differential pressure light, the activation of the MCAS, and the stick shaker, according to the report, didn't occur before the AOA vane was replaced in Denpasar. Incidentally, Please remember these discrepancies about the altimeter, the airspeed, and the stick shaker because they come up again later. After Flight 043 landed in Jakarta, according to the report, the flight crew reported some malfunctions but did not include the stick shaker and stab trim to cutout. What does that mean? It meant that Flight 043 crew did not write up the left-hand stick shaker, the stab trim issue, or the AOA disagree problems. They left those symptoms out of the turnover. To be clear, the previous flight crew on Flight 043 did not report or document issues that the accident flight crew would later experience. Why not? Good question. The KNKT report diverted attention away from those facts. These symptoms, these anomalies, they should have been reported. Reporting this information would have given the Jakarta technician the information he needed to fix the avionics problem. So why didn't Flight 043's crew report all the difficulties they experienced, such as the stick shaker, the stab trim cutting out? Why did the Flight 043's crew pick and choose what items to report? We don't know. We'll never know. The KNKT didn't ask. But let's be clear, this isn't speculation on my part. It's in the KNKT report. So let's review the accident aircraft's flight history found on PDF page 21. 3 days before the accident, the aircraft experienced some avionics problems. As far as we know, it was limited to the altimeter and altitude instrument disagrees. Technicians replaced the AOA vane 2 days later in Denpasar. So, okay, remember the AO vane was replaced, but not properly tested. The KNKT assumed the AOA had a 31-degree bias. How did the KNKT know this? It's not clear, but they probably pulled the information off the flight data recorder, the FDR, if the data was still there and had not been erased. The AOA vane's installation test was either done incorrectly or the installation test was not done at all. What is true is that the airplane should have never been released to service when an AOA vane hadn't been functionally tested. Why didn't the KNKT ask about this? Third, according to the report, the erroneous AOA resulted in different errors during Flight 043's trip from Denpasar to Jakarta. The captain to first officer indicated airspeed still disagreed. The captain to first officer altitude indicators disagreed. A field differential pressure light now came on, and a captain's stick shaker was activated. To be clear, these are all symptoms of a larger problem, a problem that, if properly troubleshot, could have been fixed before the accident flight, but wasn't. Furthermore, we're still not seeing a Boeing problem here. Avionics parts go bad. It's a fact of life. That's a repair station issue, not Boeing. It's not clear where Boeing made a mistake as far as the KNKT said they did. But now, what happened when Flight 043 landed in Jakarta? Flight 043's captain reported some malfunctions. Let me say that again. Flight 043's captain reported, according to the report, some malfunctions, but he omitted reporting about the left-hand stick shaker activation, the stabilizer trim that cut out, and also the AOA disagree alert, which the KNKT said was not available on the aircraft. I don't even know what that means, that the AOA disagree alert was not available on the aircraft. It's not likely the AOA disagree alert was offered as an option from Boeing. Most likely, this was from the interpretation from Javanese to English. I can't imagine the AOA disagree alert was not on the airliner. Perhaps the KNKT was suggesting Flight 043's crew didn't notice the alert or chose not to admit it. They noticed it. But wait, there's more. Then, without so much as a fact to base it on, the KNKT speculated about the MCAS system. Remember, I referred to this as the infamous MCAS system. The KNKT said the design and certification of this feature was inadequate, that aircraft flight manual and flight crew training did not include information about MCAS. Let me say that again. The KNKT speculated that aircraft flight manual and flight crew training did not include information about the MCAS. So the pilots were never told, according to the KNKT, that the MCAS was there. So the KNKT assumed the Boeing's MAX training didn't include any maneuvering characteristics augmentation system, the MCAS training. You see, the KNKT and the NTSB both blame the accident on the accident aircraft's MCAS. That's why I keep going back to this. That was the root cause of the accident, was the MCAS. First thing to remember, Boeing sold this B737 MAX to Lion Air with the new technology, including the MCAS, as part of the sale. So question, how could a manufacturer provide training and not include training about the new technology like the MCAS? And the answer is, it couldn't. And this is the part of the IR operator training that the KNKT and the NTSB and the media don't understand. It wasn't Boeing's training. Boeing wasn't responsible for training Lion Air's pilots. Lion Air's pilot training department, whether they were internal flight instructors or external flight instructors, took Boeing's training, adapted it to Lion Air's program. Multiple airlines at that time, even in the United States, were flying the MAX without issue. Why? Because airlines do their own training. Boeing doesn't do their training for them. Lion Air bought the B737 MAX because of the new technology. Lion Air was responsible for training its pilots, not Boeing. And as we will see, this accident had less to do with Boeing training and the MCAS and more to do with airline culture. Look, we're beginning to see an unprofessional pattern here on part of technician engineers and pilots. Flight 043's crew didn't write up in the logbook all the issues that they had trouble with on the flight from Denpasar. Again, there are three possibilities. So let me ask you, did Flight 043's pilots deliberately refrain from reporting the problems? 2, didn't Flight 043's pilots think it was important to report those issues so maintenance could address them before the accident flight? Or 3, or was Flight 043's pilots pressured, say by management, not to report the avionics issues? By not reporting all the problems experienced on Flight 043 inbound to Jakarta, the accident crew, Flight 610, when they took it out of Jakarta, took control of an airplane with multiple warning signs, indications the aircraft was broken, and the accident crew had no idea, no forewarning at all. That was not Boeing's fault. Flight 610 began its flight normally, an on-time push off the gate, an unremarkable taxi to the runway, and a normal beginning to its takeoff roll. But then, as the aircraft made its way down the runway, things stopped being normal. Long before the accident aircraft rotated off the runway, the flight crew should have been seeing some safety problems. If they had checked the maintenance logs before the flight, they'd have read about the instrument history in Manado and about the AOA vanes replacement in Denpasar, and this should have raised some questions. If they had cross-checked their altitude instruments, they might have seen some things that were odd before the takeoff roll. At 23 hours and 22 minutes and 16 seconds, at 81 knots, the flight data recorder showed growing differences between the captain's and first officer's instruments, specifically the airspeed indicators. The DFDR, the flight data recorder, digital flight data recorder, also recorded differences angles between the left and right angle of attack, the AOA sensors, which was about a difference of about 21 degrees, which continued until the accident. The DFDR indicated that the flight director on the captain's flight display showed 1 degree down, while on the first officer's flight display showed 13 degrees up. That's a 14-degree difference. At 23:20 and 33 seconds, the left-hand stick shaker activated as the airplane started to rotate and take off. At 23 hours, 20 minutes, and 40 seconds, the first officer advised the captain about the auto brake disarming and an airspeed disagree. So the first officer notices that the airspeed is getting an indication. This airspeed disagree warning stayed on until the accident. At 23, 20, and 44 seconds, the first officer asked the captain if he intended to return to the airport. So what was happening was the events Flight 043 experienced were now being seen by Flight 610 without any warning. Not because of Boeing design, but because Flight 043's crew didn't write up the discrepancies. When troubleshooting any problem on an aircraft, every symptom is important. If one symptom is missing, the technician could go off in the wrong direction to fix the problem. After the aircraft began its climb, why didn't the captain order a return to Jakarta? The captain, instead of returning to the airport at Jakarta, flew away from Jakarta and began troubleshooting the problem. For over 11 minutes after Flight 610's crew discovered they had instrument disagreements, the captain did something he never should have ever done. He started troubleshooting the airliner in flight. This was dangerous for many reasons. For one, the flight crew wasn't trained and qualified to troubleshoot the avionics. For two, the plane flew further and further away from a safe landing. 3, for over 11 minutes, the flight crew became more distracted as they analyzed the instruments instead of flying the airplane. And 4, there were 189 souls on board expecting the flight crew to operate safely. Look at this slide. Each of these 31 highlighted phrases in purple were times the captain decided to troubleshoot the airliner in flight instead of returning to Jakarta. They could have flown into unexpected bad weather or taken a chance that another issue could have arisen, all while they increased the distance back to the airport. Each of these 31 opportunities in 11 minutes to return allowed the airliner to fly further and further away from a safe landing. Because investigators at the KNKT and the NTSB, as well as the media and many so-called experts, don't know what it's like working for an airline, they can't understand training issues, management pressures to move the airplane, or what it's like to troubleshoot an aircraft. This was a cultural accident. For example, in 1990, Avianca Flight 52 crashed in Cove Neck, New York, from fuel exhaustion. In other words, the plane ran out of fuel. The reason was the airline's management wanted the aircraft to land in JFK, not its alternate of Boston Logan. Unfortunately, JFK had bad weather that frustrated Avianca's 52's crew from landing until it just ran out of fuel. Why? Avianca's management pushed the crew to ignore their training and procedures to forego safety in order to save money by landing at JFK. This was an example of an airline cultural problem. With Lion Air 610, we start to see breaks from protocol. 7 seconds after rotation, the first officer asked the captain if he intended to return to Jakarta. According to the report, the captain neither responded verbally nor gave any sign of acknowledgement. Because of the captain's neglect of safety protocol, the clock started for the aircraft to crash, 11 minutes and 10 seconds in the future. This transcript was a good case study to identify failure in employing cockpit resource management. The captain didn't take the first officer's advice into account. He shut him out. Did the captain not hear the first officer's question? Yes, he heard it. Did the captain not realize the situation? Yes, he understood it. So why did the captain ignore his responsibilities? The problem with the aircraft didn't lead to the accident. The captain's actions did, or better stated, his inaction. Flight 610's captain didn't learn from his training. It was unsafe and foolish to troubleshoot a revenue aircraft with 189 souls aboard. This type of event happened twice before with well-known accidents in the U.S. For instance, Eastern Airlines Flight 401's flight crew became distracted by a landing gear light, not realizing the autopilot was disengaged before they crashed into the Everglades. In Alaska Airlines 261's flight crew was distracted by a jam trim stabilizer jack screw before crashing into the Pacific. In both accidents, the crew became engrossed in fixing a problem that actually made things worse, causing the accidents. In finding 49, the KNKT stated, the captain's decision to continue to the destination, the destination airport, was based on the fact, they call this a fact, that a requirement to land at the nearest suitable airport in the three normal checklists was absent. Okay, that's really hard to believe. That was a spitballing type of finding. Landing at the three nearest suitable airports has been a requirement for decades. Airliners carry spare fuel for just such an emergency. I doubt there are countries that would allow an airline to land within their borders if they didn't carry enough fuel for nearest suitable airports. So the KNKT and the NTSB, they get 5 Pinocchios for that finding. Was Lion Air's management involved with pushing air pilots to fly the airplane unsafely? Would Indonesia's government allow that? That might suggest influence, that someone at Lion Air has a strong political presence in Indonesia. Lion Air is a private airline company. Lion Air isn't owned by the government. However, since 2017, one of Lion Air's co-founders has served in conspicuous positions in the government, in the president's cabinet, advising. Could this co-founder's government influence affect Lion Air's safety decisions? We don't know, because the KNKT didn't look at it. Yet, political influence can have its advantages. This might explain why the KNKT had a free hand in an investigation way beyond their qualifications, and why Boeing was the primary target of their report, while they tended to ignore all safety issues at Lion Air. Incidentally, this accident didn't hurt Lion Air's confidence in Boeing. Lion Air has 113 B-737s, 65-900 extended ranges, 38-800s, and 10 MAXs. Political influences can affect the outcome of an accident investigation. It's why the NTSB and the FAA are separated from all air operators to avoid bias. Now, as we continue this B-737 MAX series, we may yet find politics can play a part. Until next time, I'm Stephen Carbone reminding you to tab. Think safe, act safe, be safe. God bless.